Hello everyone, my name is Yash and I'm a programmer and a technologist with over 15 years of experience in IT industry. So today I'm going to talk about artificial intelligence, machine learning and a bit on blockchain. So we'll see about some of the basic ideas behind what is artificial intelligence, what exactly is machine learning, what's the difference between them, and how exactly businesses across the world are adopting these new technologies, how it is affecting our day-to-day life, and how exactly is it going to affect you as an IT professional, how is it going to affect your career, how is it going to affect your future. And we'll also touch upon a bit on the emerging technology which is called blockchain. So, artificial intelligence, or also known as machine intelligence. So what exactly is artificial intelligence? What is intelligence, first of all? Intelligence is the ability of us humans to learn from our experiences, learn from our surroundings, gain knowledge, and then using that knowledge in our day-to-day lives in making decisions. Intelligence is all about creativity. It's about detecting patterns. It's about analytical reasoning and accumulating knowledge over a period of time from the experiences, and then using that knowledge in our day-to-day life. That's what all intelligence is about. So when you program computers to do the same thing, when you make computers crunch vast amount of data, when you give computers a lot of data, and when you teach computers how to find patterns into those data, and when computers are made to make some sort of predictions or make certain decisions based on that learnings that they have had, then it is called artificial intelligence. And that process where you give this kind of data and you make a computer or a machine aware of the kind of patterns that the computer is supposed to find from that data, that is called as machine learning or computer learning or artificial learning. So even though we are hearing these terms AI and machine learning a lot these days, it's actually not a new term. These are not new technologies. The technology goes way back in 1955. Back then, a professor of mathematics, Professor John McCarthy, called a conference called Dartmouth Workshop, in which he invited a bunch of statisticians, mathematicians, scientists, and they all came together to discuss about the ideas of how to take the learnings and make machines do the tasks which are normally reserved for humans. So the idea was that every aspect of learning and the features of intelligence can be defined so precisely in mathematical terms that computers can be made to learn in mathematical terms, and then computers can be made to use that information so that computers can learn themselves, and then they can perform tasks which are normally performed by humans. So the idea was to develop machines that can recognize speech, that can be creative, that can create content, that can recognize images and graphics and that sort of stuff. The idea was that computers would be able to do that in a couple of decades, but it's been more than 7 decades since then. Computers have not really reached that stage. Even though significant progress has been made into various fields, computers are now able to do a lot of things much better than even humans can do. For example, graphics recognition, image recognition. Computers are now so good at recognizing some of the images that they outperform humans in that. So there are some practical examples where this sort of knowledge and this sort of technology is being put into practice, and it is outperforming humans. For instance, cancer diagnosis. So a doctor looks at an X-ray or at an image, and then doctor then tries to predict whether the person has cancer or not using the years of accumulated experience and knowledge that the doctor has. Some of the computers have now outperformed human doctors with years and years of experience, and they are making better predictions at looking at these images. So these are some of the uses at which AI and machine learning is being implemented. Back in 1997, AI had its big leap when IBM's Deep Blue computer beat the reigning chess grandmaster Garry Kasparov at game of chess. Till then, it had never happened in the history of computers and artificial intelligence that a computer had beaten a human at chess. Now, chess is a very complex game. There are trillions of combinations and millions and billions of moves, and so IBM developed this computer called Deep Blue, which used machine learning and artificial intelligence, and it beat the number one grandmaster in chess at that time, Garry Kasparov. So how did IBM do that? How did Deep Blue manage to beat a human at their own game? So what Deep Blue used to do is it had an evaluation function built into the game. So before making every move, the computer, using sheer brute force and computing power, would calculate the probability of win for every possible move on the board. And based on that data, it would decide which is the best move to make. And it would redo all these calculations at each move, not just computer's own move, but also the move of the opponent. So computer, the Deep Blue, had a database of thousands and thousands of previous games by other grandmasters, and it also had the ability to learn from the mistakes that it made. So IBM had other grandmasters play chess with this computer, and the Deep Blue learned from that experience. It stored those experiences and it made itself better, and that's how it was able to beat Garry Kasparov. Now, of course, it's 2018 and we have much more computing power at our disposal, and all these gaming engines have become even stronger, they've become smarter, they've become faster. Now you are able to play very complex kind of games, and so Go is one example. So Go is a Chinese game. It's far more complex than chess. It has many more combinations. And Google has a company called DeepMind, which uses artificial neural network. So we'll talk about artificial neural networks in a while. So it utilizes artificial neural networks. So Google created a game engine called as AlphaGo, which consistently beat the top-rated human champions of this game. And then Google did something else. They created an even better version of AlphaGo called as AlphaGo Zero. Now, AlphaGo Zero, what it did was AlphaGo Zero played games with itself. You see, AlphaGo or the Deep Blue before that or any other artificial intelligence system needs a bunch of seed data, historical data on which it can train itself. So you need a treasure trove of data, a lot of data on which the computer will then run its algorithms, it will learn from that data, and it will look at that history, and then it will make its future decisions based on that data. However, AlphaGo Zero, what it does is it does not need any seed data. Once you have programmed the rules of the game, the computer will play with itself. It will play hundreds and thousands of games with itself, and it will then improve itself. So this is something called as an example of strong AI. Before this, all the systems of artificial intelligence used to be weak AI. Weak AI as in you give a set of rules to the computer, you give a historical data, then the computer will take those rules, apply onto this data, find out patterns into this data, and then it will make its predictions onto a future set of data. So it used to work on something called as training data and testing data. So what is training data? Training data is something that you give to the computer that these are the features, and computer will then classify that data into something, and Then you give testing data. So testing data is something that the computer has never seen before, and based on that the computer would make certain predictions, or it would give some output. So this was an example of weak UI. But a strong UI is something where you do not require historical data. You just set general rules of the game, and computer will then play with itself. And since computer can play really fast, within 4 hours the computer was able to the computer had Alpha 0 had taught itself enough of Go that it was able to beat the Alpha Go, the previous version of Alpha, which had beat some of the best human minds in the game of Go. So that is the power of AI. Now, when we say AI and machine learning, how exactly does a machine learn? So, if I give an image to a computer, let's say an image of an apple, how does the computer know that it is an image of an apple? I give 2 images to a computer, an image of an apple, an image of an orange. Apple is red, orange is orange, and so how does a computer differentiate between these two? How does a computer identify that this is the image of an apple or this is an image of an orange? So there are 2 ways of doing this. One is something called as a classifier. So you give a list of features and labels to a computer. So let's say to simplify this example, assume that we describe the features of apple into very simple terms. Let us say that an apple is round in shape, its color is red, and its surface is smooth. On the other hand, an orange is also round in shape, but its color is orange, and its surface is not smooth, it is dimpled. So let us assume, for the sake of simplicity, that these are the only 3 features in apples and oranges. And we give data about a bunch of apples and a bunch of oranges, and we give it to the computer. So imagine it as an Excel spreadsheet which has 4 columns. So one column says shape, the second column says color, the third column says the type of surface it has, and the fourth column is the label. So if the shape is round, color is orange, and the surface is smooth, round, orange, smooth, what is it? It is probably an orange. Although we have said that orange is supposed to have a dimpled surface. So you train the computer using this data. Then so you give the computer training data, then you give computer testing data. So you tell that here is a piece of information where the shape is round, color is red, and the surface is smooth. Tell me if it is an orange or an apple. So computer, based on the data that it has received previously, will do some sort of calculations. Okay. Now those calculations can be either in the form of decision trees, binary trees, or it could be in the form of artificial neural networks, and it will then give out a prediction with a certain probability. So if the color is orange, if the surface is dimpled and the shape is round, the computer will say with a fair amount of probability that it is an orange. But if you say that the color is pink, shape is round, and the surface is dimpled, then the computer is not really sure whether it is an apple or an orange. So it might say, okay, it's an apple, but the probability of it being an apple is 40%. The probability of it being an orange is 70%, because 2 out of 3 features are actually matching except the color part. So I think there's a 67% chance that it's an orange. So that is exactly how in very simplest terms, an artificial intelligence system makes decisions. It takes on data, it finds patterns, and it makes a prediction. Now, this was a very simple example. This is an example in which we decided what the features are. We decided that the shape and the color and the type of the surface is going to decide whether it's an apple or an orange. But in real world scenarios, the features are not that simple. In fact, sometimes it may be impossible for a human to set and define the features. So what do you do in these cases? So in such cases, you use something called as artificial neural network. What is an artificial neural network? An artificial neural network, which is also called as deep learning. Deep learning, what it does is it takes bunch of data as input. It does some processing. The data is then filtered out and then given to a next layer. Again, in the second layer, some processing is done. Some data is filtered out and it is passed on to another layer and another layer and another layer. And finally, at the last layer, you can get some sort of a prediction. Let me give you an example. Let us say you are trying to identify between two numbers, 0 and 1. So you are writing an algorithm, a computer code, which will scan images of numbers written by hand, and it will tell if it is a 0 or it is a 1. Now, how do you identify a 0? A 0 is round in shape, okay, and 1 is just a straight line. So how does a computer know whether the given image is a circle or it's a straight line? So computer will divide this thing into a pixelated graph. So every pixel, it is either white or black. So assume that the circle, so every circle that is filled is black, every other circle is white. When it comes to lines, the circles that form the line, they are black and the background circles are all white. Now, so let's say a circle. So what are the features of a circle? The center pixel is most probably a black one. Sorry, the center pixel is most probably a white one, and the surrounding pixels are also probably white pixels because they are empty. And then once you start finding a black pixel, then chances are that all the pixels surrounding the edge are black. When it comes to, let's say, a straight line, when it is trying to identify a 1, it does not have to be a completely straight line. It can be a slanted line, it can be a slanted line like this, or somebody can make a 1 like this. The whole idea is that it's a line. So if there is a black circle, a white pixel at the center, chances are it is not a 0. It is probably a 1. Because in 0 we know that it's a circle, there's a white pixel at the center. So if there is no white pixel at the center of the image, then probably it is a line and it is 1. So you give all this data, all this information about images to the computer, and you assign mathematical functions. Now these are complex mathematical equations. You can find out more about the precise equations because it's all about statistics and calculus. But the whole idea is that you detect edges, and then you classify these images, and then you decide a probability of this being an image of 0 and this being an image of 1. Then you take the output, and once you take the output, you measure whether the output that is given by the computer is correct or it is wrong, and then you give that feedback back to the computer, so computer can then adjust the values. So this process helps happens multiple times, and with every iteration the computer improves its algorithm, the numbers that it assigns, the weightage it assigns to all the pixels, and ultimately it comes with every iteration, with more data it receives, it becomes better and better at predicting the outcome. So this is precisely how computer vision works. It's again, I've explained it in very, very, very simple terms. It's not as simple as it sounds. It is mathematically very complex operation. And if you need to know more about this, precisely how exactly it is done, then there are a lot of resources out there in the internet. You should go and check them out. Now, so machine learning. There are lots of frameworks. See, machine learning and AI works on two things. One is ability of computers today to perform a lot of difficult tasks. We have ample amount of computing power available. The kind of computing power that you have available now on your mobile phone today is much more than what was available on Apollo 11 when it landed on moon. So with the kind of computing power that we have, making all these calculations and calculating all these formulas and functions, it has become really easy. And another thing that makes it easy is that there are lots of open source frameworks available for us to get started with machine learning. So TensorFlow, which is an open source machine learning framework from Google, it is a very good resource for you to start with. Again, on TensorFlow, a lot of information is available on the internet. There are a lot of tutorials available. I suggest that you go out there online, check out TensorFlow and maybe write a very simple AI-based application, that will just take a bunch of data, testing data, learning data, train your own program, and it will give out the output. There is also an image classifier library from Google called as Inception. So let us say you want to create your own image classifier class. So let's say you want to create an application which will detect the images of roses. Okay, so you don't have to write every piece of code from scratch. You can use this library called Inception from Google. You can initialize it. You can give it a few hundred or few thousand images of roses, and you can train this. And once you give it another image of rose or any other flower, and then you can test whether this application is accurately able to predict whether this is a rose or any other flower. So AI and machine learning, we've got some idea as to how it works. Now the next question is where exactly it is used. So AI is being used almost in everything that we do today, and we don't really have to fear AI. In Hollywood movies like Matrix or Terminator, computers and very smart robots are shown as they are going to take over the humanity, but things are very, very different in the real world. What is AI doing today? AI is helping doctors diagnose cancer. AI is helping Facebook deliver better content to you. AI is helping Google serve you more personalized images. AI is helping Amazon decide the best route to ship things to you. AI is helping Amazon to suggest you other things that you can purchase. When you upload your photo on Facebook and Facebook automatically detects your face and your friend's face into that is AI, computer vision and machine learning put into picture. So AI is doing a lot of things, and is it going to take away your job? That's the question. If your job is repetitive, then most probably it will be taken away by AI. AI today is driving cars. Autonomous cars are being developed by companies like Tesla and Uber, and probably a driver's job is going to go away. But if you learn AI, if you learn how machine learning works, then there is a sea of opportunities waiting for you. So, and there are lots of open source AI frameworks out there. As a student of IT, as a student of technology, you need to learn Python, because most of these are Python based applications. Learn Python, learn C, go online, download all these AI and ML libraries. So there's TensorFlow from Google. There is something called a scikit-learn, which is a Python library. There's Terrano, and there's a Microsoft Cognitive Toolkit. There is a ML framework available from Amazon as well. You just go online, you just search for it, and just get started. Okay, so that's about machine learning and AI. Now let's talk a bit about blockchain. So blockchain is something that we hear a lot these days. What is blockchain? Blockchain is a technology. Again, that is not really a new technology. It has been been there for a while now, almost a decade-old technology, but it came into prominence with the emergence of Bitcoin. Now, Bitcoin, as you might know, is a digital currency. It is a decentralized currency. It is not issued by any government. It just stays on a computer network, and it is all powered by a technology called blockchain. So what is a blockchain? Now, you are a student of IT, so you might be knowing something called as linked lists. So blockchain is very similar to linked lists. It is a chain of information made up of something called as blocks. A block is container of data. It contains some data and it contains the address of the previous block. And that's how it forms a chain. So every time you create a new block, you add it to this blockchain. So there are a couple of very interesting features of blockchain. One is that by design, a blockchain is distributed in nature. So it does not reside on a single server or on a single computer. Every time you want to join the blockchain, the entire blockchain copy is downloaded onto your machine. What it does is that everybody on the network has a copy of that blockchain. So for one person to go and modify an individual block becomes really difficult, because everybody on the network has to agree upon those changes. In fact, making changes into the block once they are added is impossible, because once you add a block, it is encrypted. And if you change that block, the link to the next block will break. So it is just not possible to modify a blockchain once a block has been added. Now, how do you add a block to a blockchain? Not anybody and everybody can go and add a block to a blockchain. So there is something called as a proof of work. Whoever wants to add a new block to a blockchain has to solve a complex mathematical equation and give an answer to that mathematical equation, which is used as a proof of work. And then once you provide that, you are allowed to add a new block to the chain. Now, what kind of mathematical equation? It could be a very simple equation like, give me the next multiple of 2, then the last multiple of 2, which was added in the last block. So you can say that, you started with 2, the next guy will come up with 4, then the next guy will come up with 6 and 8 and like that. So this proof of work, calculating the whole idea is that finding this solution should be a computationally difficult task. But validating and verifying this proof of work should be trivial. So if I give you that, you have to find the nth prime number, then it becomes computationally difficult. But once you have that prime number, then verifying it, becomes easier. So it is imperative that there are questions. We'll take the questions in the last 1 minute. So the whole idea is that by design, a blockchain is immutable. You cannot change the data, and the blockchain is distributed. So it gives some very unique use cases for a blockchain. So blockchain can be used into industries and into fields where it becomes where mutual trust, where establishing mutual trust between two parties is really important. For instance, in share trading, or into keeping land records, or into keeping banks transactions. These are the kind of fields where by its design, blockchain is able to give you that trust, that security, that that whatever information you are getting, it is correct, it has not been tampered with, and you have the record as everybody else has. So it becomes really easy for you to trust that information and to authenticate that information. So for blockchain, we are going to just stop at that. Blockchain is an emerging technology. A lot of research is being done, but blockchain is not a solution to every problem facing humankind. Blockchain, as you might have received, in some WhatsApp forwards, is not going to replace your doctors or your accountants or your, bank or your government. Blockchain is a data store. How you use your data store, what information do you store in that, how exactly it is going to be used, that is something that organizations and governments will have to decide. So we'll take some questions over here. So which platform is better to develop AI codes? Python is the most preferred programming language, and you can either use Linux or you can use Mac. And why Java cannot be used to make AI codes. Java can of course be used to make AI codes. Okay, so there are lots of libraries available as well for Java. Okay, I am not really, I can't really think of any library at the top of my head right now. But see, these are all libraries. So you will always, find ports into various languages of these libraries. So pick your favorite language, go find an AI or ML framework in that language, and just start using it. So do you guys have any other questions? Anybody else has any other questions? Okay, it seems like there are no other questions, so we will end it right here. If you have any other questions, you can always email us, and after this session ends, you will see a feedback option. Just leave a feedback, and I hope that this session has been helpful to you, and it has given you some idea into AI and machine learning. So just get online and start coding. All the best.